Welcome to The Explainer. Today we're diving, and I mean really diving, nearly 7 miles down to the deepest part of our planet. We're on the hunt for a secret that, believe it or not, completely rewrites the story of the Earth itself.
So, for more than 100 years, scientists have been asking what seems like a pretty simple question about the Challenger Deep in the Mariana Trench. What's actually at the bottom? I mean, what is the seafloor made of way down there?
I want you to picture this. We're talking about a place almost 11,000 meters straight down. The pressure? It's over 1,000 times what we feel at the surface. Yeah, enough to crush a tank like a soda can. And it's all happening in complete, absolute darkness. Always.
So naturally, everyone thought they'd find, rock, maybe some sand. But when scientists finally got a sample back to the surface, what they found was just alien. It was this weird, soupy, super weak mud that's like nothing else on Earth.
Okay, so just look at how bizarre this stuff is. Let's compare it to regular clay soil. This deep sea gunk has like 6 times the porosity. That means it's mostly just empty space. And the water content, get this, it's around 225%. It's literally more water than mud. And on top of that, it's incredibly weak, with almost no strength to hold itself together.
So what in the world is it made of? Well, when you look at it under a high-powered microscope, you see this beautiful, almost fragile, cotton-like structure. It's a mix of clay and silt, sure, but it's also packed with tons of microscopic debris from diatoms, these tiny little organisms with empty shells.
So here's the key takeaway, right? This is not solid ground. Not even close. This stuff is super compressible and has basically zero shear strength. It's less like soil and way more like a thick, unstable soup.
And you can imagine, this creates a massive problem for anyone trying to explore down there. Just like the researchers pointed out, if you tried to land any kind of vehicle on it, say a rover or a mining machine, it would probably just sink. It gets swallowed up by this soupy seafloor and be totally stuck.
But, this weird mud wasn't even the biggest challenge. The real problem was, how do you study it properly? To understand the life and chemistry going on inside, you can't just scoop some up in a bucket. No way. You have to figure out how to grab a sample and keep it at that insane 11,000-meter pressure all the way back to the surface.
So, to solve this puzzle, engineers came up with this absolutely brilliant device, a brand new pressure-retaining sampler. Here's how it works. A motor drives a piston down into the mud. Then, these cool elastic pedals at the bottom open up to grab a sample. After that, the motor just reverses, pulling the whole thing back into a cylinder that seals itself, locking that pressure inside.
And man, did it work. This chart shows you just how successful it was. On a dive to almost 10,900 meters, the sampler was dealing with a crushing 110 megapascals of pressure. And yet, this is the amazing part. When they got it back on deck, it was still holding over 87 megapascals inside. That's about 80% of that incredible deep-sea force perfectly preserved.
So, the mission was a huge success. In 2021, for the very first time, scientists had it, a pristine, perfectly pressurized sample from the deepest seafloor on our planet. Now they could finally figure out what was hiding inside that mysterious mud.
All right, let's get into it. Because what they found inside that sample, it just shouldn't have been there. I mean, according to the fundamental laws of ocean chemistry, it was literally impossible for it to exist.
Okay, to get why this is such a big deal, we need to talk about something called the calcite compensation depth. Scientists call it the CCD, and it's a super important, invisible line in all the world's oceans.
Probably the easiest way to picture it is like an invisible snow line for seashells. Anything made of calcium carbonate, think shells, certain fossils, can survive above this line. But once you go below it, the water becomes so corrosive that they just dissolve. They completely disappear. And in the Pacific Ocean, that line is around 4,500 meters deep.
And yet, inside the mud from almost 11,000 meters, that's more than double the depth of that dissolving line, scientists found these, perfectly preserved calcareous nanofossils. These are beautiful, totally intact, microscopic skeletons from ancient plankton.
This was just a total shock. How could these fossils, made of something that should dissolve like sugar in water, survive for 17 million years, at a depth where they should have vanished instantly? It just didn't make any sense. It was a puzzle that seemed to break all the rules.
The answer, as it turns out, wasn't about ocean chemistry at all. No, it was a geological story.
A huge, epic story about a journey that took millions and millions of years.
So researchers pieced together this incredible three-stage journey. Okay, stage one. About 17 million years ago, these little organisms lived and died in a part of the ocean that was safely above the dissolving line. Their shells sank and got buried pretty quickly. Then, stage two. For millions of years, the massive Pacific tectonic plate acted like a giant conveyor belt, just slowly carrying that whole patch of seafloor towards the Mariana Trench. And finally, stage three, which is happening right now. As that plate bends and dives down into the trench, huge faults crack open the seafloor, and that's what's exposing these ancient, perfectly preserved layers of fossils.
So, okay, a 17-million-year-old ghost story about fossils is cool, for sure. But why does it really matter to us up here on the surface? Well, the answer connects to one of the most important cycles on our entire planet.
See, because these fossils are made of calcium carbonate, they're basically a record of carbon. And finding them down there reveals a huge, previously unknown way for carbon to get pulled down or subducted deep into the Earth's mantle. We're talking about a lot of carbon. Scientists estimate it could be over 680,000 million tons every million years just in this one trench.
This one single discovery completely changes how we have to think about the global carbon cycle. The old way of thinking was that, hey, these deep trenches are way below the dissolving line, so no real carbon from sediment is getting pulled down there. Well, we now know that's just wrong. There's a major pathway we never knew about, and that fundamentally changes the planet's entire carbon budget.
It's just such a powerful reminder, isn't it? That there are still these huge, profound secrets hidden away in the most extreme corners of our world. I mean, if the deepest point on Earth can hide a secret for 17 million years, a secret that actually changes how we view the whole planet, it leaves you with one last really exciting question. What else is down there, just waiting to be discovered?